concepts. In the first two classes, we didn't have anything. The first one, of course, and the second one, we didn't have much. So that's why this is our first daily concept puzzle. Please participate no matter what, and even if you're wrong, it's okay. Okay. I got the chat. Thank you. Good. So to find the x and y intercepts for any function or of any function, we set for x-intercept and for y-intercept. To find the x-intercept, we set what?
X equals to 0.
For the x-intercept.
Y equals 0.
Good. And for the y-intercept.
X equals 0.
Awesome. Please remember that. Awesome. A piecewise defined function has blah, blah, blah branches. One or two or three? How many?
Is it 2?
Several. But you are right. At least 2.
Okay.
Absolutely. At least 2. Yes. It has several. You may have 2 or more, but at least 2. Awesome. When graphing a piecewise defined function, branches or the branches overlap. I'm missing a word. What do you think? When graphing a piecewise defined function, the branches overlap. Very good. Cannot ever overlap. So if this is one function, this cannot be the other. This is not a function anymore. If this is one branch and this is the other, by the vertical line test, this is not a function. So please do not graph something like this. They can never overlap. Awesome. When evaluating a function, we first, blah, 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 what the function is, blah, 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 us. And here's an example. When evaluating a function, we first, what the function is, what do you think? What do you think? First, we have to analyze. We have to analyze what the function is, or if you don't like analyze, understand what the function is what? Telling us. What is this function telling us? What does it say to us? The function of something. What is it telling you? What is it telling you?
It's a quadratic.
-3 times whatever to the 4th. Then what else is telling us? Plus. Plus. Anyone?
Plus 2.
Yes. Times whatever to the 3rd and -4. Because this whatever can be anything. Not for all functions. So for example, if I have something, I'm pushing my computer. Yes, of course. Yes, I had to do it. Didn't I? I had to prove myself wrong. Okay. What about such a function? What is this function telling us? What is this telling us? We're analyzing or trying to understand what the function is saying. What is this function saying? F applied to x is applied how?
1 over
Whatever minus 3. Excellent. But the question is, can whatever, here I said x can be anything on the previous example. Anything. Because this is a polynomial function. Poly function. But what about here? Can x be anything?
Yeah. It can't equal 0 to make the equation 0.
So what cannot equal 0?
The denominator.
Exactly. This piece cannot equal 0. And when we solve, what will we say about x?
It cannot equal 0.
We have to move the negative 3 to the other side. It changes its sign, so then x cannot equal 3. How will I write the domain of this function? The domain of this function is written in interval notation like this. All real numbers. For polynomial functions, from negative infinity to infinity, always the case. But how do I write the interval notation for the domain of this function when x cannot be 3? How will I write it? And then I would like to go back to a piecewise defined function again. Anyone remembers how to write the interval notation for anything but 3? So this should say anything. Yes.
Negative infinity
Yes.
to infinity.
Negative infinity to 3.
Parenthesis. Union symbol. Parenthesis again. Yes. So this is the union or symbol. Union or. Since we are here before we choose a piecewise defined function, what about a function like this? What could be the problem here? So basically, for such a function, for rational functions, like f of x equals 1 over x minus 3, denominator cannot be 0. For any rational function, the denominator cannot be 0. And we already determined the domain for this one. But what could happen here?
You can't square root x minus 3?
No, we're finding the domain. We want to find the domain. We're not solving for anything. We are only trying to find the domain of this function. How do I find the domain of this function? Moving forward, I reviewed right now, I remember forever that a rational function cannot have 0 in the denominator. That's one thing. When we talk about polynomial functions, I don't have any problem. The domain is always everything. But now this is a different function. So this is a square root. function. So how do I find the domain? What could be the problem? The problem here is division by 0. Division by 0 is a problem. But here, what could be the problem? Anyone remembers?
Is it that it can't be negative?
Yes, awesome. Not the answer, but the quantity under the square root has to be positive or 0. If this is even, well, it is even. We don't write it. We know it's 2. We know it's 2. So how do I write the restriction or the condition that I have to solve to find a domain then? Perfect. That's the idea. Now, if it is odd, if the index is 3 or 5 or 7, no problem. Anything works. So the domain for this function will be everything, forever. You can plug in anything you want if the index is odd. But if the index is even, there is a problem, like for this one. The denominator cannot be 0. So then what would be the condition or the restriction that I have to state? So the inside, which is x minus 3, has to be what do you think?
What was the question again?
So we're trying to find the domain of this function. When we find the domain for rational functions, we know the denominator cannot be 0. When we find the domain for a square root function, we know that the quantity under the square root, this quantity, has to fulfill these conditions. How do I write that? X minus 3 must be
It's not x plus 3, is it?
so the quantity under the square root is x minus 3. That quantity has to be positive or 0. How do I write that? How do I write that x minus 3 has to be positive or 0? Anyone?
I'm not sure. 3 comma 0?
Greater than or equal to 0. We are going to solve, again, the same thing. We are moving x negative 3 to the other side. So the domain of this function is bracket 3 to infinity. So in x, you can plug in anything from 3 to infinity, and you will get a real number. But if you plug in x equals negative 5 or negative 4, negative 4 minus 3 will be negative 7. You cannot take the square root and obtain a real number. This will not work.
How did you know it was less than or greater? What is it less than?
Greater than or
to?
equal to 0. Greater than or equal to 0.
Okay.
Only numbers that are 0 or positive are greater than or equal to 0. Okay, so any questions for me, please? Anything? So please remember this. It's very important to know how to find the domain of radical functions.
Can you please go over it one more time?
Say that again, please.
Can you please go over it one more time?
Which part?
From the start, because unfortunately, I just came in and I'm confused.
When you mean from the start, you mean you're talking about the radical functions? Are you talking?
I'm not sure. Because I came in and you went towards the end, so I don't.
Right. So I will post the videos, right? I will post the videos of the class. Or you can stay after class and we'll talk about what you missed. I'll be more than happy to help you.
Thank you.
One or the other. It's up to you. Or both, actually. Good. So I would like to go back to a piecewise defined function. So right here in R.2. I hope I'm not logged out, please. Okay. I think okay. If you have picked a piecewise defined function for us, let's copy it and graph it. Does anyone have questions on piecewise defined functions? Maybe we should just look at one more example, yes or no? I need your input.
Yes, please. Can we look at another one?
Yes, of course. So let's choose. We know how to evaluate. We know how to identify functions. So we want now to we looked at something like this. So let's look at something like 3 branches. Let's say 69. In 69 we have f of x, negative x for less than 0, 4 for equal to 0, and x plus 2 for greater than 0. Perfect. So we want to graph this piecewise defined function.